Absolute value. The absolute value of a number is its distance from another number on a number line. Distance is a measurement that tells you how far you've gone from one point to another. The notation for absolute value is two straight lines, like this. The absolute value of 4 is 4, because 4 is 4 places from 0 on the number line. Negative 4 is also 4 places from 0 on the number line, so its absolute value is also 4. Absolute value is always a positive number, because it's the distance from the other number, in this case 0, no matter the direction. Here's Lucy. She needs to walk to her tuba lesson, 3 blocks from the bus stop. After walking 2 blocks, she realizes she dropped her sheet music. She goes back 1 block, finds it, then continues to her lesson. One way to represent Lucy's journey is like this, by walking 2 blocks forward, 1 block back, and 2 blocks forward. Lucy ends up 3 blocks from the stop, yet she walked more than that. Absolute value shows us how much she actually walked. 2 blocks forward, plus 1 block back, plus 2 blocks forward, for a total of 5 blocks. Phew! Absolute value can help us calculate distance and solve math problems.
So that's what we're going to be looking at today. We're going to be looking at solving absolute value problems. We have understood that absolute value is a distance, so it always has to be positive. So a lot of times what we're going to be doing is we're going to be getting 2 solutions when we're solving for absolute values. So the steps that we're going to be taking to solve absolute value equations is as such. So number 1, we want to isolate that absolute value. We want to make sure that it's by itself. So just like we would isolate a variable in Algebra 1, we want to move things around by addition and subtraction and multiplication and division to leave that absolute value symbol or absolute value expression by itself. Next, because there's 2 possible solutions for one value, one absolute value, we're going to create 2 separate cases. We're going to set the inside equal to both the positive and the negative or opposite value of the number on the opposite side of the equal sign. Then we solve both equations. Once we've done that, this right here, very important, we have to check for what's called extraneous solutions. And extraneous solutions are solutions that, when plugged back into the original problem. So it's got to go back to the original equation, and it makes the equation false. So when you plug it in, it is not a true statement. So we always have to check for extraneous solutions when solving for absolute value equations. So let's look at number 3 here. We want to isolate this absolute value. It's already by itself. There's nothing in front of it being multiplied. There's nothing after the absolute value being added or subtracted. So we're going to go straight to step 2. We're going to create our 2 cases. So for case 1, this is where we want to keep the inside the same and keep the out on the opposite side or the other side of the equation the same as well. We're not changing anything. We're just removing those absolute value symbols. For case 2, again, we're going to keep the inside the same. But now, on the other side of the equation, that 5, we're going to do the opposite of that, or the negative of that. Next, we solve. Add 9 to both sides here. We get x equals 14. Here we add 9 also to both sides, but instead of 14, we get 4. Now, when you check, you can just use a calculator to help you check. Just type in the absolute value of 14 minus 9 in the calculator and see what you get. That gives us 5, so it works out. And then over here as well, we're going to do absolute value of 4 minus 9, which is a negative 5. And then the absolute value of -5 is also 5. So that works out for both of them. You can just let the calculator help you solve. That way you don't have to break it up into different parts. Remember, we want to work smarter, not harder. All right, next we're going to look at number 7 here. Again, we want to isolate this absolute value. There's a 16 in front of it being multiplied. So in order to solve that, we want to divide both sides by 16. What that gives me here is the absolute value of r minus 5 equals -2. Now remember, when we take the absolute value of something, that always gives us the positive. Well, if we look here, this -2 is not positive. Therefore, there is no value of r that I will ever be able to plug in that will ever give me a negative. So, because the absolute value is equal to a negative number, we can't solve. Therefore, there's no solution. So anytime after you isolate the absolute value, if it equals to a negative number, we can't solve it. There's no solution. So for number 8, if you forget to actually look at, to isolate the absolute value, and you look at this, you're like, oh, there's a negative there. It's got to be another no solution. However, my absolute value is not isolated. We need to isolate first before we can determine whether or not there's going to be a solution. So here, to get rid of this fraction, we multiply both sides by -2. And that leaves me with the absolute value of y minus 10 equal to positive 12. So now that -6 has changed into a positive 12 after we've isolated the absolute value. This is a possible problem to solve. So we're going to do our 2 cases. So first case, we have y minus 10. We keep the inside the same, and we keep the 12 the same. For case 2, we keep the inside the same, but we do the opposite of the other side of the equation. And then we solve. We add 10 to both sides. We get y equals 22. Add 10 to this side. We get y equals -2. And then we check. So again, we got to go back to the original problem. So the absolute value of 22 minus 10 over -2, does that equal to -6? 22 minus 10 is 12. Absolute value of 12 is 12. Divided by -2 is -6. And then we go back to the original and plug in our y equals -2 minus 10. And that divided by -2, does that equal to -6? So -2 minus 10 is -12. Absolute value of -12 is -2. It's positive 12. 12 divided by -2 is a -6. That works out. So both of these are possible. So those are my answers here. Those are my answers here. They both work out. Number 9, we want to isolate here. We want to leave that by itself. So we need to add 11 to the other side. And then we can see here, 6 is equal to the absolute value of 8 minus p. And 6 is positive, so we can do that. So my case is here, we're going to keep the inside. And if you want to, you can put the 8 minus p first and then make that equal to 6 if that's something that you'd like to do better. Or you can leave it as 6 equals 8 minus p. It doesn't matter. My second case, we're going to keep the inside and make the opposite side of the equation negative. So there's our -6. I'm going to subtract 8 here to solve. We get -2 equals -p, but I don't want a negative p. I want a positive p. So remember, that's the same thing as multiplying the whole equation by -1, which changes that -2 to a +2. Here we subtract 8 to the other side. We get -p is equal to -14. Well, that means my positive p is just a +14. All right, then we check. Again, go back to the original. 8 minus 2, and then minus 11. We do the math. That works out great. And then here we go back to our original. 8 minus 14. Absolute value of that, minus 11. Again, that works out. Just use your calculator to help you out there. Remember, your calculator does have the absolute value symbol that you can use to solve these problems easily. So both of these are possible solutions. I'm going to jump down to 10 right below that. Here, we want to multiply both sides by 9 to be able to isolate that absolute value by itself. That leaves me with 3a, absolute value of 3a plus 12 equal to 0. Now, because this equals to 0, we don't have to create two cases. We just need one, because there is no opposite of a 0. There is no positive or negative. It's neutral. So there's only one case here. So we subtract 12 to the other side and divide by 3. We get negative 4. And then we check, again, back into the original. 3 times negative 4 plus 12, absolute value of that, divided by 9, should give me 0. So the 3 times negative 4 is negative 12, plus 12 is the absolute value of 0, divided by 9, which is 0. And lastly, we want to again isolate this absolute value, so we're going to add 5n to the other side. So that leaves me with the absolute value of 8 minus 2n, and that equals to 6n plus 2. Now be careful here. Now on the opposite side of the absolute value, we have an expression. We have 6n minus 2. That doesn't change the rules. We're still going to set up our two cases. So our first case, we're going to keep everything the same. So we keep the inside the same, and we keep the 6n plus 2 the same. But for our second case, we keep the inside the same, but we do the opposite of that second side. So the opposite of a positive 6n is a negative 6n, and the opposite of a positive 2 is a negative 2. So again, we want to look at the opposite. All right, so then we solve just like before. So here I'm going to add 2n to the other side. So we're left with 8 equals 8n plus 2. And then we're going to subtract 2 to the other side. We get 6 equals 8n. Divide both sides by 8. Reduce that fraction. We get 3/4 equals n. On the other side, I'm going to add the 6n to the other side just because that gives me a positive n. So 8 plus 4n equals negative 2. Then I'm going to subtract 8 to the other side. We get 4n equals negative 10. Divide by 4. We get n equals, and I'm going to reduce that fraction to negative 5/2. And then we got to check. Back to the original, absolute value of 8 minus 2 times 3/4 is equal to, actually not equal to, minus 5 times 3/4 equals 3/4 plus 2. And like I said before, if you just plug everything into the calculator, the way that it is written, because we have an absolute value symbol in our calculator, it becomes a lot easier to simplify that. So I'm going to plug into my calculator. Absolute value, I'm going to hit math, go over to number, hit enter. Absolute value of 8 minus 2 times 3/4. And then outside of the absolute value, minus 5 times 3/4. And I get 11/4. On the other side, 3/4 plus 2, I also get 11/4. It works out. When I try the other side, absolute value of 8 minus 2 times negative 5 halves, and then minus 5 times negative 5 halves. Does that equal to negative 5 halves plus 2? So again, I'm going to go to my absolute value and then do 8 minus 2 times a negative 5 halves, and then minus 5 times negative 5 halves. Hit enter, and I get 51 halves, or 25.5. On the other side, negative 5 halves plus 2 gives me negative 1/2. That is not the same. Therefore, the only possible solution is 3/4. This is an extraneous solution. So the only possible solution here is 3/4.